Good morning, dear students. In last class, we discussed about some examples. Now we have to draw some graphs of the velocity and displacement executing simple harmonic motion. And another one is displacement and acceleration. Now one graph for the displacement and velocity of simple harmonic motion. Always we have to remember that the displacement velocity graph of a particle executing simple harmonic motion, that is nothing but, its shape is nothing but an ellipse. Why this? I'll tell you. It is nothing but, first one is the displacement velocity graph. Displacement velocity graph of simple harmonic motion. I will write directly here. Simple harmonic motion. Now, according to we have an equation for that ellipse is there. What is the equation of ellipse? That ellipse equation is here. That is equals to x divided by a plus or minus, it is y divided by b is equals to 1. This is the equation of ellipse here. So we have to prove like this. We have to prove like this here. Okay. Now, first one, if the graph is like this here, along y-axis will take the velocity. I'll take the velocity of the simple harmonic motion along y-axis. It is positive and it is negative here, okay? Because it is minus p. Along x-axis, we'll take here the displacement of the particle. That displacement is called as y. It is positive and it is negative 1. Okay. It is called origin. At origin, the all components are 0 here. See, at y-axis, according to geometry, at y-axis, the x component is 0, and at x-axis, the y component is 0 here. It means what? Along this x-axis, that v should be 0. Along this y-axis, that displacement should be what? 0 here at this point. See, we already know one graph for this, it means velocity and displacement. If the particle starts from its mean position, what is that? The displacement is 0 now. At mean position, displacement is 0 here. From here. At extreme position, the displacement is what? Y is equal to maximum, it is a plus a. And it is moving like this continuously, and at mean position again what? The displacement is 0, and it is moving in a negative direction. What happened? That displacement is equal to minus a because it is negative direction. Again it is like this. But the velocity, if the velocity is taken, but the velocity at mean position is maximum. Velocity at mean position at maximum, it means what? V is equals to maximum. It is a positive, so it is nothing but what? A omega, because it is a positive. And it starts from like this. At mean position, at extreme position, the velocity is 0 here. And again, when it is moving in negative direction like this, when it is moving in negative direction here, at mean position again, what happened? The velocity is maximum in negative direction, a omega. It is minus omega. Minus of a omega is there. Then again at extreme position, it means what? Like this. At this position, what happened? It is 0. V is equal to what? 0 at extreme position. Then again, like this, it is maximum. These are the graphs of what? The displacement as well as the velocity of the particle. It means what? At mean position, when we start from the mean position, consider this as a mean position. When it is a mean position, the velocity is what? 0. It means what? At x component, it means At x component, the v is 0 here. Here the v is 0. But I'll take this is a maximum displacement of the particle here. Maximum displacement. This is a positive. This is negative. It means what? Here up to here. It is what? A. Consider this is a A. Y is equal to what? A. It is a maximum. And the particle starts to rotate like this in anti-clockwise direction. It is moving like this here, and it is at this position. At this position, what happened? The y component is there. It is there. Y component is there, but x component is 0. X component is nothing but what? Displacement. At this position, y is 0, and v is equal to what happened? It is a maximum, right? So maximum in positive because it is a positive. Maximum positive means what? At mean position. It means it means what? At mean position. At mean position, it is maximum. At mean position, maximum it is. This is the mean position of y-axis. That's why it is a mean position. It is what? Maximum. Then what happened? A into omega plus. Then again, when it is moving negative, come to here. Displacement is there. Come to negative here. If it is moving negative, then become what? Minus. Then this will be moving negative up to here. Then again what? Y is equals to minus C, maximum. Then what happened? The velocity is like this. If it is like this, what? V is equals to what happened? That V is equals to minus A into omega. This is if you join these all lines like this. This is the shape of the ellipse like this. What is that? It is an ellipse. It is nothing but what? The graph. It is nothing but the graph of displacement and velocity gives an ellipse. It is nothing but what? An ellipse. It means here that velocity and displacements are there. According to the velocity is nothing but A is a maximum and it is constant, it is right. But the velocity now depends on here the omega. If it is that, depends on the omega. What happened? If the omega is equals to 1, it means what? It is a unity. If the omega, one condition is very important here. First one is if omega is equal to 1, the graph of what? The graph become what? A circle. Here the graph is a circle here. If it is less than 1, means its component become less here. If the omega is less than 1, then that become what? Ellipse. Because if it is equals to 1, it means what? Consider this is what? Consider this omega is equals to 1 now. Then V is equal to A. A is nothing but what? It is a maximum displacement. Here also A, here also A. Then it become what? Completely circle. Yes, it's completely what? A circle here. So that if it is equals to 1, that graph become what? A circle. If it is less than or greater than 1, that become what? Ellipse. Like this. Now these are the very important points of the displacement, the velocity graph of that, of simple harmonic motion. Next thing is the very important point is the velocity is over, then acceleration, and next is displacement and the acceleration graph. Okay, next is the displacement and acceleration. Okay, that acceleration displacement graph is there. If here we already know that the displacement at the main position is 0 as well as the acceleration also 0. If the extreme position. At extreme position, the displacement is at one extreme position, or it is nothing but what? Positive extreme position. Like this now. Here positive and here negative, and it is a what? The main position. Positive extreme position, the displacement is maximum at that point. That acceleration is maximum in negative direction. That is maximum in what? Negative extreme position. Like that. We have already drawn the graphs here. Because here if y is equal to a now, one condition, if y is equal to a, when it is a at mean position, sorry, at extreme position, then if y is equal to a, then what about the acceleration? The acceleration is minus of omega square into a, minus of omega square into a, because it is a maximum in negative direction. If you take here, if the y is equal to what? 0 at mean position, then again the acceleration is also 0. Again the acceleration is also 0, because we have the general form of that acceleration is equal to minus omega square into y for that. Like this. Next thing is we have to draw this one. It means what? The displacement acceleration graph is always a straight line. Okay? Now, here the displacement acceleration graph is always a straight line. It is a straight line. How it is? I'll draw one diagram here. Along x-axis, I'll take here the displacement of the particle. Okay? A is nothing but it is maximum displacement. It is a plus a and it is a minus y is there. Along y-axis, I'll take here the acceleration of a particle. Acceleration, it is a positive acceleration and it is a negative acceleration. We have one part is very important. You draw like this or like this, anything. If the particle, it means what? The in positive acceleration is nothing but when the, I'll draw one diagram here about that, this one. At mean position here, the displacement is what? 0. Here at mean position the displacement is 0. At extreme position the displacement y is equal to plus a. This should be plus a. When it is that? It is, if it is y is equal to plus a, what about the acceleration? If you draw here the acceleration is equal to what? Acceleration is equal to what? Minus of omega square into y is a form. At mean position, y is equal to 0 now. If it is also 0, then acceleration is also what? 0. But at extreme position, y is equal to a now. Positive. Y is equal to a. Then what happened? It is minus of omega square into a. Minus omega square into y, a nothing but it becomes like this. At here the what? Acceleration is equal to minus omega square into a, because it is negative. It means y axis is negative, x axis is positive. Here what? X axis is positive. This is what? Plus a. Then y axis is what? This is a negative in this direction. In this direction means this is nothing but what? Not at here, at one position. If it is y is equal to plus a and this one is equal to what? Omega square into y. That position is nothing but here. At extreme position, these two extreme positions must be same according to this graph. This extreme position same. At these positions, what happened? This is the acceleration. A is equal to minus of omega square into a. And the displacement is what? A here. The displacement is only a. And if you draw like this, okay, like this. These are the graphs of what? Displacement and acceleration. Displacement and acceleration of a particle executing simple harmonic motion. But is here very important part is, take here the A is equals to plus of omega square into A, here the minus of A, here y is equal to what? Minus A, here y is equal to plus A, here A is equal to minus of omega square into A. Here A is equal to minus of omega square into A. Then it is the origin. That's over. But the acceleration of the particle is always directed towards the its mean position. One very important point is, here the acceleration of a particle is always directed towards mean position. Always the acceleration of the particle is always directed towards the mean position of the particle. Using this one, we will draw like that. But the displacement acceleration graph is always a straight line here. Next thing is here the energy of the simple harmonic motion. Energy of simple harmonic motion. Next part, very important part is the energy of simple harmonic motion. We already know that, we have studied that in energy there are two types. One is the potential energy, another one is nothing but that kinetic energy of a particle. Kinetic energy, which depends on the velocity of a particle, but the potential energy depends on the position of a particle. Now one thing, here the two types of energy. First one is types of energy. First one, I'll take the first one is kinetic energy. I'll take the only one thing in today's class we will discuss about only kinetic energy. The kinetic energy of a particle executing simple harmonic motion. We'll mention that kinetic energy as here only K. Okay, that's it. K is the kinetic energy of a particle. Now one thing, very simple is there. Kinetic energy is what it is according to. It is in the account of what? The velocity of a particle. It is on the account of what? Depends on the velocity of a particle, executing simple harmonic motion. Its form is, the kinetic energy form is K is equals to 1 divided by 2 m into v square is there. Where m is the mass of a particle. M is the thing about what? The mass of the particle, and v is velocity of particle executing simple harmonic motion. Yes, it is right. If it is like this, that kinetic energy is equal to, we have to substitute the velocity equation, but we have the equation of velocity. We have two equations of velocity. We have the two equations of velocity. One thing is a into omega into, if it is a na, so a into omega into cos of omega t. Plus phi is there. Phi is nothing but what? This is the initial phase, call it as a 0. Then under, or it is also equals to what? Omega into root of a square minus of y square is the y is the displacement of a particle. Okay, this is the form. When you write, we have to substitute this value of b in this equation. From equation number 1, the kinetic energy is equals to 1 divided by 2, 1 by 2. M is the mass of the particle, it is said. And b square is there. I will substitute this one. Okay, it means it is one step is less here. If you write this one and we have to convert again like this. Again it is omega under root a square minus of y square. Its square is there. The square is there. The square is related to the all terms of the bracket. Okay. Now here 1 divided by 2 m into it become what? Omega square. Omega square is there. Square is over. Next into bracket is there. It means what? Root and square gets cancelled. It becomes what? A square minus of y square is there. Then final equation of the kinetic energy is 1 divided by 2. Expand the bracket here. M into omega square into a square minus of 1 divided by 2 m into omega square into y square. Very simple. That kinetic energy in this equation, the kinetic energy never be negative. And again, the total energy is never be negative here. But first one thing is, if it is at mean position y equal to 0, if it is y is equal to 0, it is a maximum. This is a maximum condition because it has a maximum displacement A. Then it becomes maximum. Otherwise, at extreme position, it is at mean position, it is 0. At extreme position, y is equals to A, then A square it become what? A square. This is completely cancelled itself. That the kinetic energy becomes 0. It means it is depends on velocity but it is acts as same as the velocity, because if the displacement is 0 at mean position, velocity is maximum, the same as the kinetic energy also what? If the displacement is 0 at mean position, kinetic energy is again what? Maximum. The same, it acts as the same velocity. In next class we will discuss about its graph of the kinetic energy and the potential energy. We will discuss in next class. Thank you.